Nomenclature in chemistry, especially for organic compounds, previously I discussed about the nomenclature, trivial name, then various type of their nomenclature methods, that is substitutive nomenclature, conjunctive nomenclature, additive nomenclature, replacement nomenclature, subtractive nomenclature, radio function nomenclature, locants, then general nomenclature, prefixes, then bicyclo, and last one. Now I describe about the symbolic representation in IUPAC nomenclature. What is the signification of symbolic representation? As per example, symbolic representation means comma, semicolon, full stop, spaces, hyphen. Okay, they are also important when we write IUPAC nomenclature of any organic compounds. So when we retain any organic compounds, sometimes we see semicolon, sometimes we see hyphen, sometimes we see comma. So these symbols is obviously important, otherwise we cannot retain. We need not retain, but we need to write this because they have some significance. First one, comma. Commas are used to separate locants that present in the same part of a number of atoms of a no name, that is locants, of a series, and to separate letters or letter combination that show a fusion site in name of fusing. Commas are used to separate locants that present in the same part of a no name, that is locants of a series. Means in same or different atom, if there should be same type of functional groups are there, so on that case we can use comma. Okay, as for example, there must be 2 Cl is present, right? So we can use 1,2-dichloroethane, because obviously there should be in 2 position 2 carbon having 2 different position, right? If we consider in 1 carbon is 1 position, so obviously other carbon in 2 position, but both having same functional group, that is chlorine. So on that case, when we designate these 2 chlorine functionality, we can use comma to separate the locants that present in the same part of the compound. Okay, that is locant of a series. And to separate letters or letters, sometimes letters also separate out. So that's why letter combination that show a fusion site in name of fusing. So overall what we get it, in any organic compound, to separate out the locants, maybe 1, 2, 3, 4, maybe alpha, beta, gamma, maybe A, B, C, D, we can retain comma in between of them. And also in some fused ring or in some higher ring compounds, there should be combination of numerical and letter are present. So in that case there should be 3, 2 and B. 3, 2 are numerical, there is no confusion. B is a letter. So this is a combination of numerical and letter. So in between of them we can retain commas. Okay. So this is the significance of comma. That should be commas are used to separate locants that present in the same part of a compound. This is not name this is a compound, okay, and locants of a series, and to separate letters or letter combination, maybe letters A B C D, or maybe 1 2 3 4, maybe alpha beta gamma. They are same type of letter, can be separated out by comma, or there's maybe some combination can be there, that is 1 2 3 4 A B C D. They are combination of letter and numerical, we can say comma in between of them to separate out. So this is the to separation, for separation we can use comma, okay. Okay, so 1,2 dichloroethane, that is in one position one chlorine group is present, in other two position carbon having other Cl. So we can say dichloro, that is 2 chlorine are present, but their locants are different, that is at one carbon one chlorine present, and other carbon, that is second carbon having other chlorine. So we can say 1, 2, that is hypen dichloroethane, 1, 2, then hypen dichloroethane, okay. Similarly, thiono in bracket 3 to hypen B, that is pura. Now we check it, the name actually not pura. Comma. Puran, that is only puran. There should be N is not given in that side, that is must be puran. Okay. So thino 3, 2 hypen B furan. Okay. So there should be combination of 3, 2 and B. In between of them we can written, between of these two locant 3 and 2 we can written comma. Okay. This is the functionality of comma. Next one, colons. Colons are also important. Colons are mainly used to separate related sets of locants present in the compounds. That is also related. They are not only the separation of two locants. There should be separation of two related locants. Can be separated out by colons. As for example, there should be, if we consider terphenyl, there must be two linkages. One is 1, 1 prime. Other is 4 prime and 1 double prime. Okay. There should be 1 and 1 prime is related, right? Another is 4 prime and 1 double prime is related. Okay. So in between of them we can written colon. This is a related. This is also related because first two phenyl ring are attached with it by the linkage of 1 and 2 prime, 1 and 1 prime linkage, okay, and other two second and third phenyl group attached due to 4 prime carbon and 1 double prime carbon. So related locants are 1 1 prime and 4 prime 1 double prime. So in between of two related locant set we written colon, okay. So colons are mainly used to separate related sets of locants present in the compounds. If a higher level of separation is needed, there should be semicolons are commonly used. Sometimes if comma is not enough to designate to separate out the things, we can use comma. We can use colon. Okay. There are already 1 1 prime are separated out by comma. 4 prime and 1 double prime, that should be separated by comma. So then after of this we have to need another symbol to separate out the two sets. So we need colon. Okay. As for example, in a class, everyone having their own names. They having their own names because to designate to separate from the all. Okay. If one having the name A, other having the B, we can designate this girl is A and this girl is B. Okay. But sometimes in a class, more than one people having same name. So name is not enough to separate one person from the among. So on that case we need roll number. Okay, for each and every student having one and only roll number in a class. That's why due to this roll number we can classify that this girl is not the same with the other. This girl having it's their own existence. Okay, similar thing can be there. Everyone having their own names, and by this name we can get identity of everyone. But sometimes more than one people having the same name. On that case there should be confusion arise. So due to confusion we can simplify using roll number, because each and every student of any class having one and only roll number. So that's why we can justify all of the things. Okay, similar analogy, if comma is not enough to separate all the locants, for higher level of separation we need semicolons or colons. Okay, and also if there must be sets of locants are there, that is suppose in roll number when in lower class we take viva, there should be sometimes say that is first 6 are come, then again the 6 students are come, then again 6 students are come. So there should be lots of sets. Okay, there should be lots of sets which having 6 students among of the sets. Okay, so similar things when we justify that is locants are in set and these sets are separated by columns. Okay, next one, hyphen. Hyphen also important, that should be used in separation of locants from the words. In most of the cases we see there should be in between of locants, that is this is locants and it is word, we get hyphen, right? In previously written they are also same, that is this is locant, this is word, and in between of them we get hyphen, right? So first things is justify, that is hyphen is used in separation of locants from the words. So hyphen can be written in between of locants and words. Okay, second one, used in adjacent locants referring to various parts of the name. If commas are there in between of locants, this should be designated, that is these locants are present in the same part of the compound. But if hyphen is used in between of adjacent locant, it referring various part of the name, various part of the name or compound. Okay, used in stereo descriptor and name of the compounds, that is over stereo descriptor and name of the compound can be designated by hyphen also. Hyphen can used for clarity of the name of the compound. Okay, used in two parts of the designation for a primary fusion site in a nomenclature of the compound for a fusing system. If a fusing system, there should be primary fusion site can be designated by hyphen. Okay, used in two parts for the designation of a primary fusion site in a nomenclature of the compound for a fusing system. Okay, in a fusing system we can see there should be in that position also hyphen are used. Okay, in that position hyphen also used in bracket. Sometimes long hyphens are also used in the nomenclature of compounds. Sometimes this small hyphen, sometimes the long hyphen can also be used. There the examples are, first one, N-acetyl hyphen N hyphen 2 hyphen naphthyl benzamide. Okay, so N-acetyl, N means nitrogen bear acetyl group, that's why we can term as N-acetyl. So there should be hyphen are used in between of N, nitrogen and acetyl group. That should be designated, that is how nitrogen is related to acetyl group. If we any how we see that is nitrogen hyphen acetal, there should be first reminded that is maybe that nitrogen having linkage with acetyl group. Okay, COO can be attached with nitrogen. So on that case we can say that is nitrogen hyphen acetal. Then again hyphen nitrogen, a hyphen 2 hyphen naphthyl. So this nitrogen, this nitrogen also have a linkage with 2 naphthyl group. Okay, 2 naphthyl, there should be hyphen will be there. Okay, 2 hyphen, not hyphen, double bond is there. So 2 naphthyl group. And benzamide, we know that is benzene ring, that is COONH2 group is called benzamide, and there the NH2 is substituted by 2 naphthyl group and acetyl group. That's why we can say this is a benzamide derivative. And if we retain the whole of the name, we can say N-acetyl hyphen N hyphen 2 naphthyl benzamide, because this benzamide nitrogen having acetyl group, that's why N-acetyl. This nitrogen having 2 naphthyl group, that's why N hyphen in bracket 2 naphthyl, and all over the skeleton the simplest form is benzamide. Actually benzamide having the NH2 group and this NH2 group are derivatized or substituted in this structure. Okay, actual their simplest form is what? That is must be benzene ring, that is must be COO, this is C, and that should be NH2. Okay, now this NH2 is substituted by one acetyl, other is 2 naphthyl. Okay, now there should be one thing, that is in naphthyl, in that position is termed as 1, and in that position termed as 2. That's why we termed as 2 naphthyl. If we draw that is benzene ring and that is naphthalene ring, this position is 1, so this position is 2. Okay, okay. Next one, N hyphen 2 chloroethyl and hyphen N1 methyl 2 hyphen phenoxyethyl, then benzylamine. There should be the simplest structure is benzene ring. Okay, benzene ring, that is must be CH2, then NH2. This is the actual parent structure of this compound. Okay, now the question is, these 2 NH2 is substituted by one is 2 chloroethyl group, another is 1 methyl 2 phenoxyethyl group. Okay, by this analogy, by this way we can get this all over the compound. Okay, the simplest form of this second structure is benzylamine. That's why we term the parent compound, that is benzylamine. Okay, but now this two hydrogen of NH2 group is substituted by 1 2 chloroethyl group. This is another is 1 methyl 2 phenoxyethyl group. This is okay. That's why we termed as N hyphen in bracket 2 hyphen chloroethyl, then hyphen N hyphen in bracket 1 hyphen methyl hyphen 2 hyphen phenoxyethyl, then bracket close, benzylamine. Okay. Next one, there should be 2 chloro in between of nitrogen and bracket we get 1 hyphen, because designate that is nitrogen is connected with this whole over the unit. Okay, nitrogen is connected by this whole over the unit, that is 2 chloroethyl is connected with nitrogen. So by this way we can get that is nitrogen hyphen in bracket 2 chloroethyl. Okay. Then hyphen similar N hyphen. This hyphen also designate, that is there should be the nitrogen is attached with 1-methyl 2-phenoxyethyl group. This nitrogen attached with 1-methyl, because if nitrogen is attached, there should be taken this carbon is 1, 2, this is 3, this is 4, 5, 6, 7, 8. Okay, so this is termed as 1-methyl 2-phenoxy, because this CH2 is attached with phenoxy group. Phenoxy group means benzene ring. If there is OH, that is should be called phenol. If there must be OH, is termed as phenol. Okay. Now, if one OH is abstracted, so we can get phenoxy. Okay. So this CH2 attached with phenoxy group. That's why we termed as 1-methyl, because one carbon atom bears one CH3 group. That's why 1-methyl. Then hyphen 2-phenoxyethyl, because two carbon the 2 carbon that should be connected with phenoxyethyl group. Phenoxyethyl means phenoxyethyl, because that is benzene ring O CH2 connected. That's why it's termed as 2-phenoxyethyl. Okay. So 2-phenoxy overall is ethyl. Okay. That's why it's termed as 1-methyl 2-phenoxyethyl, because 2 carbons is there in between of them. This is. If we consider first one justification, 1-methyl, because one position having CH3 group. 2-phenoxy, because 2 carbon bears phenoxy group, and this overall is termed as ethyl. That's why we termed as 1-methyl, 1-methyl, then hyphen 2-phenoxy, and overall ethyl. Bracket close, benzyl. Okay. So that is justification, that is N-2-chloroethyl, because if we consider this is 1, so that should be 2, and this 2 ethyl group is attached with 2 carbon of ethyl group is attached with chloride group. That's why we termed as 2-chloroethyl. Okay, 1 carbon is attached with nitrogen, so 2 number carbon that should be attached with chlorine. That's why we get 2-chloroethyl. Number always started after heteroatom. Okay, so there should be, if N CH2 and CH2 is there, so this is will be 1 and this will be 2. Okay. So by this way we can term as 2-chloroethyl. So N hyphen in bracket 2-chloroethyl, because this unit is attached with nitrogen. Then hyphen N 1-methyl 2-phenoxyethyl, that is 1-methyl 2-phenoxyethyl overall, that is ethyl, right? And that should be attached with nitrogen, so we get N 1-methyl 2-phenoxyethyl, and ultimately we get benzyl 11. Okay, so while the name is, that is that is N hyphen in bracket 2-chloroethyl hyphen N hyphen in bracket 1-methyl hyphen 2 hyphen phenoxyethyl bracket close, benzyl 11. Now full stop. Full stop is used to separate numerical ring size indication in names constructed according to von Baer system employed in Spiro compound. Sometimes when you see that is in Spiro compound, there should be written in bracket 2, 2, 1. So in between of these two numerical, we have to use full stop. Okay, to designate the ring size. Okay, if we consider Spiro compound, so we also written there must be 2, 3. So there must be written as full stop. Okay. How we know that is in bicyclo compound? In bracket, that is highest number of carbon atoms written in first, then mid number of carbon atoms, then lowest number of carbon atoms. Similarly, in spiro compound, there should be opposite 10. First one, that is lowest number of carbon atoms written first, then highest number of atoms. That's why in that case, the designation is 2 to 1, highest to lowest, and there should be designation is lowest to highest, 2 and 3. Okay. So bicyclo 2 to 1, in between of 2 to 1 ring size, we have to consider full stop. Okay. Bicyclo 3 to 1, there should be 1, 2, 3, 1, 2 and 1. That is 3 to 1, the carbon atoms of each of the ring designated by full stop. That should be separated by full stop. In spiro, similarly, that is in between of 3 and 4, we have to retain full stop. Similar 3 to 2 to, that's why we retain full stop. 4 5, we retain full stop. In between of 4 5, we can use full stop. So we can justify there should be 3 6 8, that is similar type of locant. In between of them, we can retain comma. Okay. The locant and the word in between of these, we retain hyphen. Okay. Then next one, in bracket we use, second bracket we use full stop. That is, what is there? That is 3 6 8. In between of 3 6 8, 3 6 8, each are locants. In between of locants we write comma. This locant and this word, in between of them we must write hyphen. And for in square bracket, for especially for bicyclo and spiro compound, we use full stop. Next one, spaces. Most important type of punctuation in nomenclature in organic compound. First one, obviously punctuation is most important for organic compound. As for example, pH, this is called phthalic acid. Okay. But if we pronounce P and H before the phthalic word, we can use phthalic acid. But actually the punctuation is phthalic acid. It's important. As for example, psychology, there should be P is there, but we have to consider first pronounce S. Okay. So used in separation of more than 2 functional groups present in the compound. If there should be more than 2 functional groups are present in the compound, for separation we can use spaces. If more than 2 functional groups are present in a compound, on that case for separation we use spaces. Spaces means the places. Spaces means same things, places. In between of them there should be gap is there. Okay. Also separate words in additive names in nomenclature of compound. Sometimes words, if they are additive names, so for separation we use spaces also. Now some examples. First one, acid and their derivative, the carboxylic acid ester and anhydrides are there. So first one we have to consider that a acid is there which having RCOOH group. Okay. If one OH is replaced by chlorine, we get acid chloride. If replaced by fluorine, acid fluoride. If that should be produce COOH is replaced by OR group, that is COOR group, then that should be OR group. That is termed as ester. Okay. And if this OH is replaced by only R, we get ketone. This OH is replaced by hydrogen, we get aldehyde. This OH is replaced by OCH, COOR, that should be termed as anhydride. Okay. So first one, that is called acetic acid, CH3COOH, which having CH3 alkyl group that should be attached with carboxylic functionality, that is COOH. Now this OH if replaced by CH3, we get methyl acetate. There should be O is there, I think. Okay, in between of this. This is actually what I written as acetone. But if we written methyl acetate, we have to consider CH3COOCH3. Okay. Next one, acetyl chloride, that is CH3COCl. If OH is replaced by chlorine, we can say acetyl chloride, as there should be CH3 as alkyl group, so we can say acetyl chloride. If CH3 is not there, R is there, so we can say that is acid chloride. Acid chloride is a general term. That should be the name vary due to variation of R group. Okay. Next one, ethanoic anhydride, that is CH3COOCH3. We can say this is ethanoic anhydride. Then potassium sodium succinate, that is potassium sodium succinate. Why? This is all about CH2 if we consider CH2. This is also CH2. This is called as succinic acid. CH2COOH and CH2COOH are termed as succinic acid. But when that should be replaced by any metal that should be react to produce anion, it should be called succinate. And as in that case, here sodium is present and here potassium is present, so we can term as potassium sodium succinate. Potassium sodium succinate. How we know? There should be in IUPAC name, we have to consider alphabetical order. PQRST. So P is come first, then S. So that's why potassium is written in first, then sodium, then succinate. Okay. Succinate is nothing but that is a carbon ion. That is a carbon ion, not no carbon ion. That is a carboxylate ion is produced. Okay. This is called succinate. Okay. Dianion is produced, that is dicarboxylate. Okay. So that is termed as succinate. That is, as there should be two metal are there, metal ions are there, that is potassium and sodium, and that's why we termed as potassium sodium succinate. And P, obviously if we consider alphabetical order, that is potassium come first, then sodium, then succinate. Okay. This is ethanoic anhydride. Ethanoic anhydride. We know that is COO bond O bond COO is present in any type of compound. We have to consider anhydride. Okay. And there should be two ethanoic, means CH3COO are attached to itself by oxygen linkage. So we can say ethanoic anhydride. Okay. Next one, carbonyl compounds and their derivatives. Carbonyl compounds, there should be ketone, can be possible. Aldehyde can be possible. Oximes can be possible. Acetal hydrogens. First one, dimethyl ether, there should be two CH3 attached with COO group. So we can dimethyl ether, dimethyl ketone. Okay, that is COO attached with two CH3 group. Then next one, ethyl methyl ketone, because in one side ethyl group is present, in other side methyl group present. So the R groups are not same, so that's why we do not use di or bi. We have to use ethyl, then methyl, then ketone. And we know that is E is come first, then M in alphabetical order. So we use first ethyl, then methyl, then ketone. Okay. If COO react with NH2OH, okay, so we get ultimately acetone oxime. Oxime, that is nothing but COO group replaced by C double bond NOH group. Okay, that should be called acetone oxime, because acetone oxide derived from acetone, that is CH3 COO and CH3. react with NH2OH. Okay, then it must be produce acetone oxime. Acetone react with NH2OH, we get acetone overall the oxime derivative. So that's why we term this all over the oxime acetone oxime, because it is produced from acetone. Okay. Next one, acetone cyanohydrin. Cyanohydrin, why? Because this is also produced from acetone, so that's why we termed as acetone cyanohydrin. And that should be react due to CW group react with HCN, or that is, we can better say HCN, and this CN minus react, and this can be there, and that should be produced COH, and that should be CN. Okay, and this is termed as cyanohydrin. If CBW is there and HCN, suppose HCN can be attacked, CN can be attacked, and this should be attacked, and that should be produced COH, and that is must be CN, this. That should be termed as cyanohydrin. And as there must be both of sides CH3 is there, and that should be derived from acetone, so we can say acetone cyanohydrin. Now the question is, HCN, can HCN attack? HCN is most of the cases HCN is not attack actually. If they attack, is very difficult. So on that case we can use the ionic compounds, that is as for example KCN, as per example NaCN. These are because they are fully dissociated to produce CN minus nicophile. But if we consider HCN or any organic compound, there should be CN does not exist as CN most of the cases. HCN there should be, can be little bit attack can be possible, but it's very difficult because sometimes HCN produce not a fully ionic compound. Okay. And in other compounds, as for example CH2CN, as for example CH3CN, CH3CH2CN, there is no free CN minus is present. There should be C bond, C triple bond N are present, and this is not fully dissociated. This is not a free enough to attack on carbonyl. Okay. But when we use ionic compound, as for example NaCN, as for example KCN, there should be CN minus is free, so CN minus can easily attack to carbonyl and produce, that is cyanohydrin. Okay, so we can use better ionic compound which having CN minus. Next one, if this is same acetaldehyde oxime, there should be same things. In acetone we get acetone oxime, from aldehyde we get acetaldehyde, from acetaldehyde we get acetaldehyde oxime. If there should be CH3 and COO and H, that should be react with NH2OH, we get ultimately acetaldehyde oxime. Okay. If this NH2 not react, there should be, if in place of NH2 react NH2, that is hydrazine, then we get acetaldehyde hydrazone. If acetaldehyde react with hydrazine, that is NH2, we get overall one water molecule is removed, so we get overall acetaldehyde hydrazone. Okay, due to hydrazine we get the compound from carbonyl is nothing but is a hydrazone. Next one, halogen compound. First one, acetyl chloride. As there is CH3 COOH, that should be replaced by Cl, so we can call that is acetyl chloride. Okay. Again, other is tert butyl bromide, because tert butyl means, that is, tert means 4 carbon. Okay, tert means 4, and there should be actually 4 carbon attached with bromine. Tert butyl means in a space there should be 4 carbons are attached, and this whole of the 4 carbon combination are attached with bromine. That's why we termed as tert butyl bromide. Next one, oxygen compound. Oxygen compound, there should be so many, that is alcohols if OH is present. As for example methyl alcohol. If CH3 as the R group, So on that case we termed as methyl alcohol or methanol. Okay, sometimes ethers can be there if there should be linkage O bond O is there, as for example CH3, and there should be CH3, we termed as dimethyl ether, because two methyl group are same, so that's why we can use di prefixes. So we can use dimethyl ether. If there should be CH2 CH is there, should be CH2 CH is there, so this is not identical. In one side CH3 is present, in other side CH2 CH is present. So there we do not use any bi or tri prefixes, so we have to consider that is ethyl, then methyl, then ether, because E is come first, then M in alphabetical order. So we use first ethyl, then methyl, then ethyl. And peroxy also oxygen having peroxy group, that is must be this. Two oxygens are attached. So that's why we termed as peroxy. That is termed as peroxide. We know this is comes from H2O2 hydrogen peroxide, because there should be HO bond O linkage is there. That's why we termed as peroxides. Disulfide, that is where there should be S bond linkage. Okay, and there should be both sides ethyl group is there, so prefixes is used diethyl, then disulfide. Okay, this is termed as disulfide linkage. And this is only sulfide, there should be only S is there, sulfide, and there should be in one side ethyl group is present, in other side methyl group is present. These are not same, so that's why we know ethyl methyl sulfide. As we know E is come first, then M in alphabetical order, so we can say ethyl methyl sulfide. Okay. Okay. Now the whole of the summary is first one comma used to separate out the locants in between of them, which should be present in same part of the compound. Okay, and also is used in bracket also. These are the examples. Second one, colons. Colons are used for separated the sets of locant. If similar type of locants are categorized in a set, on that case this set are separated by colons. In that case, in 1 prime and 4 prime 1 double prime, that should produce two set, and these two related set are separated by colon. Okay, because 1 prime show one linkage, that is in between of first and second phenyl group, and 4 prime and 1 double prime, that should be other linkage that should be produced between second and third phenyl group. So due to this, these 4 locants can be produced two related set, and to separate out the two set we have to use colon. Okay, and also colon used in a higher level of separation where comma is not enough. Okay, hyphen used basically in between of locants and words. If we start words after finishing the locants, in between of them we have to consider hyphen. Hyphen also consider for adjacent locants referring to various part of the name. There must be the difference between hyphen and comma. For comma we use the adjacent locant that should be present in the same part of the compound, and hyphen basically used for adjacent locant referring to various part of the name. Okay, used in stereo descriptor name of the compounds, and designation the primary fusion site in nomenclature of the fused ring system, and sometimes long hyphens also used instead of small hyphens. There should be examples, that is N-acetyl hyphen N hyphen 2-naphthyl benjamide. The first structure is the simplest form of benjamide. Okay, so there should be this NH2 is substituted by one acetyl group and other 2-naphthyl group. That's why the name is N-acetyl hyphen N hyphen in bracket 2-naphthyl benjamide. Similarly, the other terminology, there should be the second structure is benzylamine, benzene CH2NH2, but this NH2 is replaced by 2-chloro, substituted by 2-chloroethyl and 1-methyl 2-phenoxyethyl. That's why the name is produced, that is N hyphen in bracket 2-chloroethyl hyphen N hyphen in bracket 1 hyphen methyl hyphen 2 hyphen phenoxyethyl bracket close benzylamine. Next one, full stop used. This is for basically in the ring size the in between of name, for indication we have to consider full stop. Especially for bicyclo and spiro compounds, we have to consider this type of numbering in bracket. In between of these two number, we have to consider full stop. Then spaces also important. First one we have to consider punctuation. Punctuation is most important. Then we have to consider spaces. Spaces is separation, more than two functional group is present in the compound. So we have to separation, we use spaces. And for also separate words in additive names in nomenclature of compounds. And this is the examples that acid and their derivative, like carboxylic acid, ester, anhydride. Carbonyl compounds, their derivative ketone, acetals, oxime, hydazones. And then halogen compounds, oxygen compound, alcohols, ethers, peroxide. So first we consider if the compounds having the COH group, that is termed as acid. If this OH is replaced by chlorine, we can term the acid chloride. If this OH group is replaced by fluorine, we can say acid fluoride. If this OH replaced by OCOO group, again that should be produced anhydride. If this COO, then if we consider NH2, we can say amide. If you use CO, then OR, we can say ester. And when we consider carbonyl COO group, if there should be in both sides alkyl group is there, that is termed as ketone. If one R group is replaced by hydrogen, we can term as aldehyde. If RC double if replaced by NH, that should be termed as imine. If this is replaced by NH2, that should be termed as hydrazone, because that should be produced by reaction of carbonyl and hydrazine. That's why we term the produced compound as hydrazone. If there should be NOH, that should be termed as oxime. If is there this type of compound, that should be termed as cyanohydrine. If there must be, okay. Now, if there must be O bond R, that should be termed as ethyl. If O bond O linkage, that should be termed as peroxine. Again, if this type of linkage is there, that should be termed as disulfide. If this type of linkage is there, that should be termed as sulfide linkage. Okay. If any alkyl group having the OH, that should be termed as alcohol. And if benzene having OH, that should be termed as phenol. Okay. If benzene having this CH2 group and then OH, that should be called benzyl alcohol. Okay. So this is the term. If benzene having this CH2 group and then linkages are there, that should be termed as benzyl position. Okay. If say, okay, up to this. Okay.